Hey, Algebra 2, welcome. Let's jump right into it. 8.5. We got a quick review of our 30, 60, 90 and 45, 45, 90 triangles, okay? Sine of 0 is 0. Sine of 30 is a half. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And sine of 90 is 1. Cosine is 1. Cosine of 0 is 1. This one's root 3 over 2. This one is also root 2, and this one is a half. You see how those two are switched? Try to remember that. And this one is 0. You see how these two are switched, right? And then lastly, tangent of 0 is 0. This one is undefined. Or how about I wrote D and E does not exist. And then tangent of 30 is root 3 over 3. Tangent of 45 degrees is 1. And tangent of 60 degrees is root 3. So we've covered these values before. Just a quick review. I hope that you fill this in. Or you can Google trig table and this will come up as well. So sine of 45 degrees, boom, root 2 over 2. Cosine of 30 degrees, boom, root 3 over 2. And tangent of 60, boom, root 3. I'm just looking at the table. I think you can look at the table too, right? Boom, sine of 90 degrees. We're just finding those values on the table. Okay? Now, what about going the other way around? If I told you cosine of theta equals 1, what is theta? 0 degrees, because that is where it's equal to 1. If sine is 4/8, well, guess what? That's a half. So where is sine equal to a half? Boom, at 30 degrees. Tangent is 5 over 5 root 3. These would cancel, and I would have 1 over root 3. Multiply that by root 3 over root 3, and guess what? I get root 3 over 3. Where is tangent equal to root 3 over 3? 30 degrees, according to the table. And this is 1. Where is sine equal to 1? 90 degrees. So I'm just going backwards. I'm finding the trig value on the table and then saying, oh, that's a 30-degree angle. Okay? Now, why do we care? What's so profound about those measurements? Well, I'm going to pause this real quick and fill in this table once again, so that way I'm not having to go back and forth. Okay, so I took a quick second and filled this in again. So these angles we will refer to as our reference angles. Okay, let's just jump into a problem and we'll understand why it's called a reference angle. Find the reference angle for each of these angles listed below. So where is 302 degrees? 302 degrees is right. Let me not use pink. Is right somewhere around here, okay? Because this is 90, 180, 270, a little bit bigger than 270, 302 degrees. What is a reference angle? Well, yeah, it opens up all the way around like so, okay? It opens like so, but it creates this triangle right here. Correct? It creates this triangle. We have been making these in class repeatedly. We've been making these right triangles. And this angle right here is the reference angle. So if this is 302 degrees, you should ask yourself, how much further do I have to go to get to 360? 360 minus 302 is 58 degrees. That right there is a 58-degree angle, and that is my reference angle. So 165, where is 165? This is 90 and this is 165-ish, right somewhere there, right? How much further do I have to go? 180 minus 165 is 15. Right? How much further do I have to go to get to 180? I have 15 degrees more to go. Negative 473. Remember coterminal angles? To plot negative 473 is kind of weird, but I could add 360 to this, right? If I add 360 to this, what do I get? Negative 473 plus 360 gives me negative 113. You know what? How about I do it again? How about I add 360? What does that give me? 247. I don't know. Is that easier to plot? I don't know. Who cares? But they're coterminal angles. And when I plot this, where's 247? 247 is somewhere here-ish. So what is my right? I forgot to draw the right triangle over here. All right. What is that angle? And then the right triangle over here, what is that angle? So the question I'm asking now, how far past 180 am I? How far past 180 am I? 247 minus 180 gives me 67 degrees. And then last but not least, with 732, again, I don't want to deal with the big number. So use our knowledge about coterminal angles to help us. If I subtract 360, I end up with 372. If I subtract 360 again, because that's also kind of a big number, I end up with 12. If I plot a 12-degree angle, guess what? That is our reference angle. The reference angle for 732 is 12. So it's all about, when what is a reference angle? Let me answer that again. What is a reference angle? When you plot an angle, this triangle always appears, right? And we create an angle right there in that little cranny, and we create an angle right there in that little nook, and we create an angle right there in that little nook, and we call that the reference angle. Okay? So, what is the significance of that reference angle? What is the significance of that reference angle? Well, we can use it to find the value of sine, cosine, and tangent. When I plot 300 degrees, and I know it's way over here, how much further do I have to go? AKA, what is my reference angle? 60 degrees, right? 360 minus 300 is 60. I have 60 degrees right there. Well, guess what? Anything that's true about 300 is true about 60. These guys are related. They're sort of like twins, okay? So if I want to know sine of 300, all I have to do is look at sine of 60, which is in that table. If I want to know cosine of 300, all I have to do is go find cosine of 60. If I want to know tangent of 300, all I have to do is go find tangent of 60. So what is sine of 300? What is sine of 60? Root 3 over 2. So that means sine is root 3 over 2. What is cosine of 300? Let's use our reference angle. What is cosine of 60? 1/2. What is tangent of 300? I don't know. Let's use our reference angle. What is tangent of 60? Root 3. And boom. Oh, I didn't even realize they were written right here. I'm stupid. Then boom, we have our answers. But wait, there's a slight catch. Sine is negative because we're in quadrant 4. We can't forget about that, right? We are referencing a 60-degree angle, but we have to remember that 300 degrees is actually in quadrant 4. So that needs to be negative, right? Because this is a y, this is a negative y value. We're going down, okay? Now, I chose to ignore it for a little bit. There's this little trick right here. This is a little trick on how to find the reference angles. If your angle well, 495 is way too big. Let's subtract 360 from that to find a coterminal angle. 495 minus 360. That gives me 135 degrees. What quadrant is 135 in? Is it in this one? No. Is it in this one? Yes. So how do we find the reference angle? We do 180 minus 135. And I get 45 degrees. So this is my reference angle. So I refer to the table and I see that sine of 45 degrees is root 2 over 2. And I see that cosine is also root 2 over 2. And tangent is 1. But wait, we need to be careful. Remember that 135 is in quadrant 2, right? So sine is positive, but cosine is negative. So therefore sine is positive, cosine is negative, and tangent is negative. Oh shoot, I forgot to say that over here as well. Tangent is negative over here as well. Because a negative divided by a positive gives me a negative. So the sine value is positive, but cosine is negative and tangent is negative. Let's do it again. Negative 510. Why am I adding 360, or in this case subtracting 360? To find a more user-friendly, so to speak, a more user-friendly angle, right? Because coterminal angles, right, they're essentially equivalent. So negative 510 minus or plus 360. And you know what? I'm going to do it again. Plus 360. So I got negative 150, but then I want to add 360 again, and I get 210. So that's a coterminal angle, but that's not the reference angle. If negative 510 is equal to 210, 210 is going to be right here in quadrant 3, a little bit past 180, correct? A little bit past 180. So if we're in quadrant 3, we do angle minus 180. So 210 minus 180, and I get 30 degrees. So the reference angle that is created right here in this spot is 30 degrees. I know that's kind of teeny, but it's 30 degrees. So if we want to know sine of negative 510, we refer to 30 degrees. Sine of 30 is 1/2. Cosine of 30 is root 3 over 2. And tangent of 30, I never remember, is root 3 over 3. But we're in quadrant 3. So guess what? Sine is negative. Cosine is also negative. And the two negatives make a positive. Let's do it. Let's just do it one more time. Why not? It's not taking that long. 900. Again, I mean, you could draw and swirl around and find 900, but I would rather find the coterminal angle first. Find something that's a little easier to plot. Okay? Find something that's a little easier to plot. I'm going to subtract 360 again, and I got 180. Wait a minute. 180. Right? That's boop, flat. What's the reference angle for 180? Well, 0, right? It's flat. There is no reference angle, right? There is no little triangle that gets created. But also, we know this from our previous lesson. We were doing quadrantal angles, right? It all comes down to the coordinate. This is an xy coordinate, and in the unit circle, right, at 180 degrees, this was a coordinate at negative 1, 0. So this is negative 1, the x value. This is the y value, 0, and tangent is 0. But also, for the sake of the lesson, there is no reference angle. The reference angle is 0 degrees. And what's sine of 0? 0. And what's cosine of 0? 1. But because we're going to the left, it's negative 1. And what's tangent of 0? 0. Boom. So it all matches up. It all matches up in the end. I just realized that I haven't asked a question this whole time. So how about this is the moment that I ask a couple of questions. Find the exact value. Find the exact value. So here's the first question. Find me the reference angle. Find me the reference angle for this guy right here. Questions pop up on screen. Or answers pop up on screen. 210 is in quadrant 2. Or sorry, no it's not. It's in quadrant 3, a little bit past 180. So 210 minus 180 is 30. The reference angle is 30. What is cosine of 30? Cosine of 30 is root 3 over 2. So the answer to cosine of 210 is root 3 over 2. Except we're in quadrant 3, so it's negative. Now, you might be asking yourself, why don't I just plug that into a calculator? If you plug in that into a calculator, you're going to get a decimal. You're going to get root 3 divided by 2 as a decimal. We're looking for the exact value. We're looking for the fraction, negative root 3 over 2. Do it again. Find me the reference angle for this guy. Some answers pop up on screen. Okay, 120, here's 90, a smidge past, boom. We're in quadrant 2. If we need to go look back up, here it is, 180 minus theta. So we do 180 minus 120 to find the reference angle of 60 degrees. So what is tangent of 60 degrees? You go up, and you see that tangent of 60 is root 3. Is it positive or negative? Tangent is positive in quadrant 1 and quadrant 3. Okay? The all students take calculus. All of them are positive. Tangent is positive. So these two, it's negative. Let's keep going. Find me the reference angle for this guy. Answers pop up on screen. 315, 90, 180, 270, a little bit, whoa, 90, 180, 270, a smidge past it, boom, there's 315. There's 315. So what's our reference angle? 360 minus 315 gives me 45 degrees. So our reference angle is 45 degrees. All right, tell me, when I do cosine of 45 degrees, is my answer going to be positive or negative? Because spoiler alert, cosine of 45 is root 2 over 2, right? Cosine of 45 is root 2 over 2. So the answer to this is root 2 over 2, or is it negative root 2 over 2? A couple more answers pop up on screen, positive or negative. The answer, positive, because the x values are positive over here. Cosine is positive in quadrants 1 and 4. I'm going to try to wrap this up perfectly at 20 minutes, so maybe we can squeeze 1 or 2 more problems in here. Sine of 360, right, that's just going to wrap yourself all the way back around to 0. So whatever's true about 360 is true about 0. So I would just literally copy this. Sine of 360 is 0. I don't know why it's written twice, so ignore that. Oh, these are both written twice. Oh, we just did them all. Oh, okay. Why are those written down twice? That's funny. All right, beautiful. Under 20 minutes. I know I went kind of quick, but I also just hate making these videos so long. So hopefully it wasn't too quick, and hopefully you benefited from it. Looking forward to seeing you in class, and enjoy your spring break as well. I just want to put that out there. All right. Have a good one. Thanks for watching.